Good morning, friends. Today we will discuss about some mathematical applications, especially in physics. As you know, the number of concepts in mathematics that can be used in the case of deriving equations in physics, or in the case of that numerical part we can use. So in this session we will discuss about calculus part, especially differentiation, the technique of that differentiation, few formulae regarding that differentiation, and how we can use that differentiation in the case of that kinematics approaches. Let us see. First I want to give, in the case of that differentiation process, or I want to give some simple example regarding that defining that differentiation. I want to take one function y that is equal to f of x. That means the value of y depends on the value of x. That is y equal to, I want to take x square. It's a simple function. Y equal to x square. What does it mean? If you want to take x equals to 1, then the value of y that is equal to 1. Whereas if you take x equals to 2, then the value of y that is equal to 4. Here that difference in the value of x is 1. Here the difference in the value of y is 3. For example, you want to change very small increment in the value of that x. Then see the changes in the value of that y. That means here I can take x1 equal to 1. As you know, y1 that is equal to 1. Now x2 equals to, I want to take a small change, and after that 1.1 that can be considered. Then the value of y2 equals to 1.1 whole square, which is nothing but 1.21. Now what is the difference in the value of x that we consider? x2 minus x1 delta x, that is equal to 0.1. A small change in the value of x, 0.1, can cause changes in the value of y. That means y2 minus y1 equal to delta y, which is nothing but 1.21 minus 1, 0.21. Here in the value of that x there is change in 0.1. Whereas in the case of changes in the value of y, I can take that 0.21. Here you may take that delta x still less, like 0.01 or 0.001. Thereby you are able to get a small changes in the value of y too. Therefore, if I want to observe the change in the value of y with respect to x, which is delta y by delta x. Just like that, change in the value of x, let it be input. The change in the value of that y, let it be output. You are discussing delta y by delta x and limiting value of this delta x, which I can write LT, limiting delta x tends to 0. Limit delta x tends to 0. Just you are defining that limit of that changes in the value of x. Delta x tends to 0, approaches to 0. Delta y by delta x, that is nothing but, I can say dy by dx. Dy by dx, which is nothing but derivative of y with respect to x, or I can say differential coefficient. This value that is nothing but a differential coefficient. So in most number of occasions we can call this is a derivative of y with respect to x, means first order. Therefore in the case of that, I can write dy by dx, I can write d by dx of that y, that is nothing but, you can write f of x. That means you are differentiating x. You are differentiating that x with respect to x. Hence, this is a simple concept that is known as, in the case of that derivative of y with respect to x dy by dx. That means you are differentiating y with respect to x. This simple concept can be used in the case of our kinematics applications. As all of you know, in the case of that kinematics, we may study about that distance, displacement, speed, velocity, acceleration. In that cases, most number of occasions in the case of instantaneous value, for example instantaneous velocity or instantaneous acceleration, the value at that particular instant of time, if you want to concentrate either on that velocity or either on that acceleration, in that cases you have to depend upon this process of differentiation. Okay, I want to tell the simple equation part in the case of that differentiation. Actually you are having number of equations in the case of solving mathematics problems, whereas in the case of our physics we will use some problems and some rules and regulations. Thereby you may go for that effective calculations. Under that, rule number 1 or first formula, if y that is equal to x power n, then I can write dy by dx that is equal to d by dx of, here y means x power n, that can be considered as n into x power n minus 1. N is not equal to 0. For example, if the value of n that is equal to 0, anything power 0 that can be taken as 1, then here there is no x term. Therefore, d by dx of x power n, here you are able to get n into x power n minus 1. So, n that is not equal to 0. So, this equation we will use in number of times in the case of our instantaneous calculations. Similarly, if I want to take, if y that is equal to constant, that means only a constant, directly you can write dy by dx that is equal to d by dx of that constant, that can be taken as 0. Of course, for this you can use that rule number 1. Every time we may not apply that rule number 1, which is nothing but a time consuming process. Hence I can say in the case of isolated constant differentiation, that can be taken as 0. So d by dx, not only d by dx, if that is a function of time, d by dt of constant that is equal to 0. Any variable if you want to consider, that may be x or y or t or whatever it may be, if this value is nothing but constant, you are differentiating that constant with respect to that, it will be equal to 0. And in the case of that third one, if I say if y equal to some constant k into x power n, here k is a constant definitely, but this is not isolated constant. Here you are having x power n that is coupled with that x power n. In that case, then dy by dx that is equal to d by dx of, this is k into x power n. Take k as outside constant, that as outside, which is nothing but d by dx of x power n. By using rule number 1, d by dx of x power n means you can write n into x power n minus 1. So, in the case of that constant that is coupled in terms of that x power n, by the combination of first, you are able to write that final value equals to k into n into x power n minus 1. Sometimes you may not have single value. So that may be expressed in terms of 2 or 3. For example, if I want to take the fourth rule, which is if y that is equal to u plus or minus v plus or minus w, where u is a function of x, v is also function of x, and w, that is also function of x. This can also be used number of times. If y equal to u plus or minus v plus or minus w, then you can write dy by dx. Here you can write u, v, w all are in terms of x only, function of x only. Then dy by dx, that is equal to, here you are differentiating u with respect to x, du by dx, plus or minus, in the case of v you can differentiate v with respect to x, plus or minus, this is nothing but dw by dx. If that is positive sign, you can take positive. If that is negative sign, you can take that as negative. So this can also be used number of times. Whereas if you are considering y that is equal to u into v, product, u is a function of x, v is also function of x, then in the case of that, if y that is equal to u into v, both are function of x only, then I can write it's a differentiation dy by dx, that is equal to first u, that is u, and differentiate v with respect to x, dv by dx, plus next take v, and this is nothing but du by dx. So if y that is nothing but u into v, you can use this formula u into dv by dx plus v into du by dx. Here positive sign only. As you know that u and v are, here I consider function of x. Whereas in the case of that division type, if y that is equal to u by v, then you can write its differentiation dy by dx, that is equal to, first take that denominator v, differentiate numerator with respect to x, du by dx, minus u into dv by dx. Whereas in the case of that product, here you are having plus, you may write v into du by dx plus u into dv by dx. Whereas in the case of that dy by dx, especially y equals to u by v, you can write this value and denominator whole square. Therefore, you should have to consider this part which is in the form of u by v division, where u and v are once again function of x. I can write this value. So there are so many equations once again, like logarithmic function, you are able to get 1 by x. If y equal to e power x, you are able to get e power x. Like that you are having trigonometric values for sin x, cos x, and cos x, that is nothing but minus sin x, tan x, that is you can write secant square x. So you may have number of equations, but these 6 are main equations that can be used. First all of you go through that equations, that is nothing but, this is u into v, this is nothing but u by v, and in the case of fourth one, y equal to u plus or minus v plus or minus w. Okay, these concepts can be applied in the case of that physics. Here I expressed all values in terms of some x, function of x, like that. Now I want to explain one or two simple one. For example, in the case of that previous one, I said y equal to simple one, x square. Here I want to differentiate this x square, y equal to x square with respect to x. That means dy by dx, that is equal to d by dx of this x square. Here simply you can write 2x. As far as that exact theory that is considered, here this value is 2x. You are differentiating here x function with respect to x. That means you have to write 2x into dx by dx. Of course, this value gets cancelled. You are able to get 2x. Here, there is no change. Simply, you can write 2x. For example, if I want to say y equal to t cube. Now, I want to take y depends upon the value of t. Then, I want to differentiate y with respect to time dy by dt, which is nothing but d by dt of, this is nothing but t cube. Then, this is in the form of x power n means t power n, 3 into t power 3 minus 1. Here also you are differentiating some t with respect to t. Hence I can say that is nothing but dt by dt. Value gets cancelled, you will get 3d square. Here there is no issue for all of you. But if I want to take, that is nothing but x cube, that is equal to some t cube plus 1, like this. Let us consider this example. Let x cube that is equal to t cube. Now here differentiate, call this as some equation 1. Differentiate this equation with respect to time. Differentiate equation 1 with respect to time. For example, if I want to take x cube, if you are differentiating with respect to x, then you are able to get 3x square. Therefore, this is 3x square. Now you are differentiating that x value with respect to t. That means you have to write here dx by dt. That means you are differentiating x with respect to what? Time, dx by dt. For example, here if you want to take t cube, directly you can write 3d square. Here t with respect to t. Here there is no need to write that. For the case of that simplification, I am telling you dt by dt. Of course, this value that is equal to 0. Differentiation of that isolated constant that is equal to 0. Therefore, here 3x square into dx by dt. For example, x represents displacement. Here this is nothing but time. Hence, you may write this as some 3x square into some velocity, and this is nothing but 3d square, like that. So, this is a format to be considered depending upon that. Now, if I want to take some simple example, especially those are used in our physics kinematics applications. Generally, position of a particle or displacement or distance, this will be considered as yes, or you may also consider x also. For example, s that is equal to function of time. S equals to function of time, where s is nothing but, if I say position, or I can say here displacement. Now, if you are differentiating with respect to time, ds by dt, which is nothing but d by dt of that function of time, then this ds by dt, this is called as velocity v, which is known as instantaneous velocity at that instant. Therefore, v that is equal to ds by dt. If you require t equals to 1 second, after that you can substitute t equal to 1. T equal to 2 seconds, you may substitute that value. Now, I want to consider this one, v that is equal to ds by dt. If this v is differentiated once again with respect to t, dv by dt, this is known as acceleration, instantaneous acceleration. For example, if you want to go in terms of that, yes, this is nothing but d by dt of, what is meant by v? ds by dt. Therefore, acceleration, that is nothing but d square s by dt square, d square s by dt square. So in the case of that displacement, if you are differentiating with respect to time, then you are able to get velocity. If velocity that is differentiated with respect to time, then you are able to get acceleration. Whenever you want to substitute that time value 1 second, 2 second, then you are able to get the values at that instant of time. Because in the case of that speeds and velocities, you know, uniform, non-uniform or variable, average and instantaneous. This differentiation process, mathematical process that can be applied in the case of that instantaneous values. Now I want to tell one technical example which is based on that. Hope all of you can understand this one. Here I don't want to derive that differentiation process, differentiation formulae which you may learn in the case of your mathematics by using that fundamentals. Now, position of a particle varies with time. Position of a particle varies with the time by the following equation. By the following equation, that is S equals to TQ plus 2D square plus 6T plus 10. S value measured in terms of meter, T value measured in terms of second. Now calculate velocity at T equals to 2 seconds and acceleration at T equal to 2 seconds. If that is a problem, here what you have to consider, time value changes, displacement changes. You need that velocity at a particular instant of time, 2 seconds, instantaneous velocity. Here also acceleration, instantaneous acceleration. So take this as equation number 1. S equal to TQ plus 2D square plus 6T plus 1. Equation number 1. Differentiate equation 1 with respect to time. Then here you can write ds by dt, which is nothing but velocity v. Here which is in the form of u plus v plus w, like that. So differentiate individually. D by dt of here you can write tq plus d by dt of 2t square plus d by dt of that 6t plus d by dt of 10. Here directly you can write this is 3d square. Even if you want to write dt by dt, that value is 1. Here there is a plus. This is t square means 2t. Here 2. Hence you are able to get 4t. Here d by dt of 6t means it will become 6. Isolated constant, that is equal to 0. Therefore, this is nothing but velocity. For example, if you want to apply t that is equal to 2, 3 into 2 square plus 4 into 2 plus 6. Here 4, here 3, 12. 12 plus 8, 20 plus 6, 26 meters per second. Similarly, take this as some equation 2. Differentiate equation 2 with respect to time. Then you will get A equals to acceleration. T square means 2t. Here 3, 6t. 4t means it will be 4. Differentiation of isolated constant, that is 0. Hence I can write acceleration A, that is equal to 6t plus 4. Then substitute that time value 2 seconds. Then 6 into 2 plus 4. Here 12 plus 4, 16. Hence you are able to get 16 meter per second square. So velocity at t equal to 2 second, answer 26 meter per second, whereas acceleration at 2 seconds, time t equal to 2 seconds, you are able to get that value 16 meter per second square or meter second power minus 2. I think all you might have followed this one. That means you are able to calculate instantaneous velocity and instantaneous acceleration at that particular time intervals.